So we're based here in Santa Fe, New Mexico. We have an annual rainfall of about 16 inches per year, but we haven't really even got to 16 inches for a few years. We've been in a drought. This last winter, we were lucky to get some extra snow and rain. I am slightly above Santa Fe, so I maybe get a little bit more than that. What's important about that is that we really need to harvest as much rainwater as possible and use it wisely. So both passively in the landscape, capturing it, holding it in the soil, holding it in plants, but also actively catching it off of hard structures, patios, roofs, and storing it in tanks that we can use when it's dry, right? Or when the plants need it. The roof that we think is the best for rainwater harvesting is metal roof. This is a standing seam roof. You can see the small little attachments up on the metal ridges, and those are called snow cleats. So that holds the snow on the roof. At least a third of my annual precipitation is in the form of snow. So I want to hold that snow on the roof, which actually acts as extra insulation for the house. And then those cleats hold it up there instead of it sliding off and letting it melt on the roof and go into the gutters and down to the filters and into the rainwater harvesting system. So if you don't have the snow cleats, the metal warms up a little bit and the snow slides off, right? So, okay, you're infiltrating it maybe into your landscape, but in the middle of winter, your landscape probably doesn't need extra water. It's better to actually hold that snow on the roof and let it melt and go into the rainwater harvesting tanks. The snow sliding off the roof could rip your gutters off. It both saves your gutters, plus it holds the snow on the roof for your rainwater harvesting system. We have the rainwater hitting the roof, collecting into the gutters. We have gutter screens to help pre-filter the water. And then the gutters come down to these downspouts. The downspouts all connect to pipes underground and go out to the rainwater harvesting tanks. In my system, I have 5,100 gallons. In hindsight, I wish I even put in more than that, but that's kind of what we could afford when we built the house. So the front, the south-facing part is all guttered. The north-facing part of the house, I was worried about the gutters getting pulled off, and so we did a different type of collection system or conveyance system on that side of the house. One nice thing about tying tanks together, so that's my system. I have 5,100 gallons, so it's 3 1,700 gallon tanks. But if I wanted to expand, I could just dig next to the end tank and add another tank and tie it in. I am considering that because this winter was quite wet, and so my tanks were full and were overflowing for a couple months before I turned the system on for the irrigation season. And we often do that for clients. Maybe they can afford 2,500 gallon one tank, but in the future they could add. We have a job coming up soon that we're adding another 2,500 gallons to their system. With underground systems, if they're larger, we'll tie the tanks together at the bottom so that a series of tanks act as one tank, fill and empty together. And then you have that option of adding more tanks in the future. Typically here in New Mexico, or in this part of New Mexico, we have 2 wet seasons and 2 dry seasons. Typically we get rain and snow in the winter, and then we have a dry, kind of windy spring, and then we have our summer rains. So July, August is our second wet season. And then we have kind of typically a dry fall, so September, October. We typically size the tanks to help get us through that dry spring and then fill them up again on the rainy summer season, and then get us through the dry fall period before we put the system to sleep for the winter. For us, that calculation is usually about 25 to 35% of your annual rainfall, right? So if you were getting 20,000 gallons per year off of your roof, then 5,000 to 7,000 gallons, something like that would be a good size. My roof, I have large overhangs because it's straw bale on the north, and I wanted to really protect that, and adobe on the front. With the large overhangs, we have about 3,200 square feet, and also with our shed, we have our shed bringing water and also the house. So together about 3,200 square feet of roof water catchment. I'm a little bit above town, and I calced my system on about 15 inches per year. So that's for every square foot of roof space, about 1.25 cubic feet. 3,200 times 15 inches is 1.25. And then for every cubic feet of water, you get 7.48 gallons, right? So annually on average with this 3,200 square foot roof, we get about 29, almost 30,000 gallons coming off the roof. So even in an arid climate, you can capture quite a bit of water. So we're on the north side of the house. We're on the cold side. This is mostly shade. I get snow piled up here all winter. I was worried about the snow pulling my gutters off here. So I don't have gutters on the north side. So what I did instead is I just allow the snow to fall down and build up on the ground. In this catchment area, I also was able to increase the catchment area by extending a pond liner about 6 feet away from the house. And that pond liner is graded or sloped to an in-ground gutter. And they call it like drain grate, so something you might put in cement right before the garage to keep a garage from flooding. So that's in the ground. And so what we have is we have gravel on top of a geotextile that's protecting the pond liner underneath from getting too damaged from the gravel. The water just soaks through the gravel and goes into the drain grate and then goes into a 4-inch pipe to the conveyance filter before the cisterns. So some winters, like this one that was nice and wet, we had a good 3 or 4 foot pile of snow back here that just slowly melted and soaked into the conveyance system for the cisterns. So we're here on the northwest corner of the house, and on the south and west side is all guttered. So that rainwater goes through the pre-screens on the gutter and then down the downspout into the conveyance pipe. That 4-inch PVC pipe comes toward me and then meets up with the channel drain on the north side of the house this way. They connect here and then go toward the conveyance filter for the tanks. So I used a pretty inexpensive solution for my conveyance filter. I just used septic tank filters. They're about maybe $40 or $50 at a plumbing store. It's the filter that allows the solids to stay in the septic tank. It's kind of the last filter before the water exits a septic tank. So you can get them just at a plumbing store. It's like a 4-inch T filter. So this is the conveyance filter, right? So this is all the water. The conveyance pipes are the pipes that bring the water from the house to the cistern, conveying the rainwater. So you can see I need to clean this a little bit. This filter has some bugs and some pine needles and things like that. And I check in here and it's looking pretty good. This is kind of the last catch before the water goes into the cisterns. I have 2 of these filters, one coming from the south and the west side of the house, one coming from the east side of the house. Then they both drop into the 3 1,700 gallon tanks here. Again, those are tied together to act as a 5,100 gallon system. The water is pumped out of the tanks with the submersible pump and goes through. Here's a pressure gauge, and my power outlet for the pump is here, and then goes into the irrigation system and also my standing spigots for other water uses, maybe hand watering or washing something. So here's a pressure gauge just showing that we have about 50 pounds of pressure with the pump. Here's a drain, so it's always good to include a drain in a cold climate system. So when I unplug the pump, I can drain this line by opening this small valve here. And that drains all the lines that go uphill back down to this box. You always want to have a GFI protector, so that's a ground fault protector, because it might be a wet situation. So your electric plug should be protected in case this gets too much water in it or something, it turns itself off. So here's the vent, allowing the air from the tanks to come out as the water is coming in. There's 3 1,700 gallon tanks here in a series or in a parallel situation tied together in the bottom, creating a 5,100 gallon system. So also remember, if you need to increase your water harvesting area or surface areas, be creative. Think about all the other structures you might have, or even patios, barns, sheds, chicken coops, the driveway, any kind of non-permeable surface that you can harvest water off of. Try to get creative and think of how you might get that water into your system. There's considerations about doing above ground tanks or below ground tanks. We like to do the most economical system as possible, but also people like underground tanks often so that they don't have to see them, or that it also gives us a benefit of being more downslope, right? So using that gravity to get the water into the tanks. So underground tanks, below ground cisterns are more expensive. They're typically almost about double the cost of an above ground tank. Sometimes we try to make a more economical system by using an above ground tank and sinking it a little bit, 2 or 3 feet, just to protect the pipes coming in and out from freezing. You can be storing water over the winter and the pipes won't be protected from the frost. Some other considerations for underground tanks are if you dig and you have lots of rock in the excavation, you might need to bring in sand or pea gravel to kind of bed the tanks in to protect them from any sharp edges or sharp rocks. As you backfill, you want to make sure to pull any of those stones or rocks that might be possible damage to the tank in the future, get those away from the tank as you're backfilling. And then you want to actually compact fairly well around the tank so that you don't have a big sinkhole later, right? So you need to be compacting maybe every 1.5 feet as you backfill up over the tanks. The nice thing about underground tanks is you could have a patio on top, right? You could have plants on top. You kind of regain your square footage area with the underground cisterns. So that's a benefit. They are more expensive, like I said, than above ground. Typically with cisterns or even rainwater tanks, if you filter the conveyance water coming in, the rainwater coming in, you don't really need to clean the tanks. And they actually have done studies where the tanks grow a biofilm on the inside of the tank, and it actually helps clean the water and keep the water clean and safe. You do want to keep sunlight out of it. So if for your lids, you want to have black or dark lids or paint them dark. But you want to minimize the amount of sunlight that gets into any tank. So if it's an above ground tank, you want it to be opaque. If it's white, you want to paint it or get a dark green or a dark black tank so you can minimize or eliminate any algae growth. Same with underground tanks with the risers and the lids. You want to have those be dark or painted or opaque to the sun so you don't have algae buildup. Other than that, you don't really need to clean your tanks out unless there is some major event, like if you get a rodent or some animal that dies in the tank or something like that where you might clean it out. But otherwise, they should be just clean and good as long as you make sure to filter that conveyance water coming into the tank. And the water will stay fresh for months and months and months. Okay, so we're opening the cisterns for the first time from the winter. And they're full, so that's nice. 5,100 gallons of fresh snow melt and rainwater to be used in supporting our edible landscape here. We can show you some of the parts. Hopefully you can see it underwater here. So here, this is a float that is connected to the inlet hose of the pump. Sometimes on the top, like this, I dropped a little dust on the top of the water, so that's floating, and sometimes there's pollen that's small enough to get through the conveyance filter. But this allows the pump to pull right from the cleanest part of the tank, so just underneath the surface of the water. So it's not laying on the bottom of the tank where there might be some sediment. So that float moves with the water and allows the pump to pull the cleanest water out of the tank. There's also another float that turns off the pump in case the water gets too low to make sure the pump doesn't run dry. So you can see the pump is a submersible pump down in the bottom, and then it comes up and goes here out to the irrigation and standpipes. This T in a small 1/2-inch valve here is to drain this part of the line as well in the winter. So when I unplug the pump in the other box, I open this valve, drains all the water from the PVC line all the way down back into the tank. This tank won't freeze in the winter because the bottom of the tanks are 5.5, 6 feet down. So this is protected from freezing. And typically we'll want to empty our tanks in the fall before we winterize them because we want them to be ready to receive as much snowfall and rain over the winter to fill up. I usually charge up my soil in October before I turn my system off, use up all the water out of my tanks, pump it all into the soil, and then my tanks are empty for receiving winter water. We're in a cold climate here, almost 8,000 feet, so we have to winterize our systems in usually October through the end of October through early March, because our winter season is one of our wet seasons, I empty the tank. So if there's any 25% of the tank left, I'll use that up, I'll pump it into the landscape, let the soil hold that water. Then my tanks, my cisterns are empty for winter snow melt and winter rain, right? To be filling up and then be full tanks in the spring. I have not had problems with big tanks freezing. They are plastic, so above ground tanks, they have a little give. What's susceptible to freezing is typically the valves and the piping, the tubing and the PVC and the plumbing coming out of the tanks. So that's what you need to protect. Either have it in a sunny spot where it can really soak up heat with that thermal mass in the tanks. If you can have those tanks on a west or a south side in a cold climate, not on the north side. Maybe even through the coldest months, having some kind of protection or heat tape or something on any plumbing that's exposed. That's why we often bury above ground tanks if we can, 2.5, 3 feet, something like that, to kind of protect those inlet outlet pipes so that we can be capturing that winter water, winter snow or winter rains, but not have winter damage with your plumbing. If your above ground tanks can only be sited in a cold side of the house, is what we've done is in the coldest time of the year is actually maybe run a hose from the tank to places you might want to add more water. So the tank is actually just part of the conveyance system delivering water to some area, but you're not actually capturing water in the tank. We've done that before. Or maybe draw it down halfway or a part way so that if you're worried about that there's more room in the tank for the ice to bulge out or to move up. I've never had a tank split in all the time I've been doing this for 25 years, but I have seen the plumbing out of the tank be damaged by winter freezing. With my system, I am pretty hands-on with it, so I don't have a level meter on mine, but usually for clients we'll put in a level meter so you can see on the outside without opening the tanks if you're 25% full, 80% full. And if it's an automated system, you don't need, it might be of interest, but you don't really need to have that because it's going to just switch from rainwater to well water or municipal water if it's automated. But it is nice to know how much water is in your tank. So there's some that are more mechanical that maybe have a float that moves up and down in the tank that shows you how many inches of water, how many gallons are in the tank. There's others that are digital, even Wi-Fi. So in your house, you'd have a little screen that tells you have 3,000 gallons in the tank. So there's a lot of different options. So another benefit of rainwater harvesting tanks is that you have this water on hand for possible fire suppression. So that could be either pumped into your house for fire sprinklers inside the house. Sometimes we'll put in very large systems, 10, 15, 20,000 gallon tanks, and then the client would keep maybe half of that tank full with water that's never used for the irrigation or domestic use, and it's just always there in case there's a fire. And then they have a dry standpipe that's usually a 4-inch that the fire department could come and hook up to and pull water out of your tanks to use to fight a fire. I just want to encourage everyone to get out there, do some research, think about what is the best system for your site and your house. I always encourage people to do the most simple economic system with the least amount of plastic and pumps and materials if possible. Each site is different. You might need a more complicated system. Typically, the more automated you want it, the more complicated and expensive it is. See if you can really be hands-on. Try to use a very simple system if possible. Try to use gravity as much as possible. And just really value this resource, right? We have this free water that's purified that's falling on our heads and falling on our house. And how can we strategically use that water to support living soils that support edible and productive plants and provide beneficial habitat for animals and birds that are symbiotic with our system. Get out there and slow it, spread it, and sink that rainwater into the ground and capture it into tanks so you can slow it, spread it, and sink it later in the dry season.